Varies. Yeah. Today we're going to talk about, obviously, Pythagorean Theorem, how to use it, what it is, what you're finding, the ins and outs of it. So, of course, just put a picture up here for you so you can see him. Named after the Greek mathematician Pythagoras. Handsome chap there. So, of course, we got to kick it off with some vocab. Now, some of the vocab you already know. I know that you know what a hypotenuse is, okay? So I'm just going to over here kind of clarify. You can see it labeled on the picture. The hypotenuse is always the longest side. And the other thing, too, that also is a tip-off on which side is the hypotenuse, it's always the one across from the right angle, too. So that's an easy way to pick out the hypotenuse. That's going to be key today because we're going to be using the hypotenuse and comparing things to it today. Now, the other remaining sides, they instead of just calling them sides, they call them legs. So I'm going to put the other remaining right here. And let's get technical. They're shorter. They're shorter than the hypotenuse. So again, it's just the vocabulary. Hypotenuse the longest, you know that, across the right angle, and the other two sides we're going to call legs. Now, I have a pretty good feeling you probably know, maybe, hopefully, what the formula is for Pythagorean Theorem. Anybody? Jordan's over there quick on the draw. A squared plus B squared equals C squared. So in a right triangle, the length of the square of the hypotenuse is equal to the sum of the squares of the other two legs. Nothing exciting about this. Now I'm going to click it back just one slide really quick and look at that triangle again. Because of course, let's just make sure we're clear here. When you use your formula, the hypotenuse, the longest side, you have to use that as letter C. That's always the C squared side. The other two, I don't care if you do this one as A, this is B, this is A, this is B, it doesn't matter. They're interchangeable. But C has to be the hypotenuse. The other two you can mix and match. Just to be crystal clear. So find the value of x. Leave your answers in simplified radical form. So simplified radical form, direction. Yeah, we just talked about directions. That means I want them the square root style like you were doing yesterday. I don't want a decimal. I want it 5 square roots to 7. That style of answer. All right, first easy question of the day. Which side on the triangle is the hypotenuse? Got it. Thanks, Elliot. So I don't care if you start with the 8 or the 6 or the 6 and the 8. It doesn't matter. I said 8 first, so I'm going to start with that. So I'm going to do 8 squared, the other leg squared, and our hypotenuse is x. Now, really from here, this is, to me, calculator work. You can punch this into your calculator as it is. I'm just going to do a little mental math. I'm going to have 64 and 36. 64 plus 36. Again, I'm just going to add those up. And let's do a little, again, we could mental math this, I think. To get x alone, how are you getting rid of squaring? Square root it. You got it. And we don't need a calculator for that. What's the square root of 100? 10. Now, do I have more work up here probably than what you're going to have? I probably do. I probably do. Because you probably could have done some of this in your calculator, which is fine. You know, I like to get carried away with the work. That's how I roll. All right, B. Question of the day. What side is the hypotenuse? 5. So it doesn't matter if you start with the x or the 3. I said x first, I'm going to start with that. X squared plus 3 squared. Now again, I'm going to do a little mental math. We know 3 squared is 9. 5 squared is 25. Now, to solve for x, we're going to use some of our algebra skills. How are you going to get rid of the plus 9? Yeah, do it in your head. What's 25 minus 9? 16. Quick over there today, Dean. I like it. What gets rid of the squaring? Do it in your head. What's the square root of 16? Now, I'm also going to show you, too, in a minute here. I could have told you with no work this missing side was going to be 10, and this missing side was going to be 4. These are examples of what we call Pythagorean triples. I'm going to do this last problem for you in a minute, but this is what this chart's all about. 3, 4, 5 always makes the right triangle. So does 6, 8, 10. We use 5, 12, 13 a lot in trig. So if I have 5 and 13, I automatically know the other side's 12. I don't have to do any work. So just to show you or to reference some Pythagorean triples, do you have to have this memorized? No, but that's what we're going to talk about here in a sec. All right, let's finish this last one. Question of the day. What's the hypotenuse? X. All right, I don't care if you start with the 6 or the 4. It doesn't matter. I'm going to start with 6. Now again, you could just punch the left side into your calculator. 6 squared, 4 squared. I don't need a calculator for that. I got it. What's 36 plus 16? 52. All right, we already know we're going to square root. Now, here's a throwback to yesterday. You can't, because of the directions this time, give me a decimal. Because if you punch that in your calculator, it's a decimal. It asks you for a radical. So I'm thinking about my list of perfect squares. Oh boy. What's the biggest perfect square that goes into 52? 4. 4 goes into it how many times? You can use your calculator for that. I don't expect you to know that. I heard it, 13. Okay, square root of 4 is what? 2. So 2 root 13. Got it. Any questions on that? So, just for the record, if it asks you for radical form, I need it this style. If it says you can use your calculator and round to the 10th, punch it in and give me a decimal. Just read the directions close. All right, we kind of already talked about this triple page a minute, but let's just kind of revisit it for a second. So, again, do you have to have these all memorized? No. But if you have some of the common ones done, it does save you some time. So I knew 6, 8, 10 is a triple. So I would have, with no work, done anything and would have just slapped down 10 here. Same thing on this one. I know 3, 4, 5 is a triple. So I could have done no work and knew that that missing side was 4. So some of the common ones, of course, 3, 4, 5, I'm going to circle that guy. And notice, all they're doing to get all these other values, they multiplied by 2. Then they did 3 times 3, 4 times 3, 5 times 3. Then they multiplied by 3 to each of them. They're just multiplying them. I don't get crazy and memorize everything underneath. I know 5, 12, 13 is pretty common. You might see that again. And I would say 6, 8, 10 is probably one of the more common ones too. If you recognize those, it's kind of a shortcut or a hack. You won't have to do any work. You can just figure out and slap down what the missing side is. But again, you don't have to have them all memorized, just for the record. Just showing it to you. So this is we already kind of talked about. Again, read the directions closely. When it asks you for a simplified radical form, if you have like the square root of 12, you would give 2 root 3. If they ask you for an approximate decimal answer, that's when you punch it in your calculator. So it's just a matter of reading closely on what style I want your final answer. Not that big of a deal. Just read close. All right, a lot of great examples, practical uses of your Pythagorean theorem. You can see on this very lovely picture, flagpole shown is supported by 2 wires. Find the length of each wire. Round your answer to the nearest tenth. Okay, good. We can use our calculator. Okay. So you can see you've got your, I'm going to use the left one here, your 2 right triangles. So you got your 8.5 at the bottom. Then just because they didn't want to make a mess, they kind of put it on the side here. The height is 15.1. I'm going to label it. And we're just really going to use our Pythagorean theorem. Obviously, our hypotenuse across from the right angle is our x side. I'm going to start with the bottom, the 8.5 squared. And then our height, our vertical side, the 15.1 equals c squared. Okay, obviously you need your calculator. Punch in the left side, see what you get. And then you know you're going to have to square root it. So see if you can go to a final answer. just the sound of calculator keys so soothing. All right, what do you got? 17 point. Jordan, say it. You got it. I'm going to round it to the 10th. I'm going to put 17.3. And I guess I should get fancy and label it since it's a word problem. I'm going to put feet. All right. Any questions on that? Wasn't too bad for a word problem. Okay. So similar type of problem, but a little meaner because you don't have a picture. So, okay, we're going to have to draw our own picture. I'm not too worried about that. Top of the ladder rests against the wall 23 feet above the ground. The base of the ladder 6 feet away from the wall. What's the length of the ladder? Well, no mystery here. What sort of picture, what sort of shape do you think our picture is going to involve? What type of picture we had every single problem? A triangle. We're going to have a right triangle. So I'm just going to start with our kind of a generic right triangle here. My artistic skills in play. All right, next question. Read closely. Top of the ladder rests against the wall. Which side of the three on the triangle is the ladder? The bottom, the vertical, or the slanted? Slanted. So I'm going to label it L for ladder. That's as great as my artistic skills get. I had some kids drawing some really nice ladders in my other class. I'm not that good. Okay, 23 feet above the ground. So which side's 23? The bottom or the vertical? Vertical. Okay, the ladder, the base of the ladder, 6 feet from the wall. So clearly our bottom is 6 feet. Find the length of the ladder. So of course, this is now just your standard Pythagorean theorem. Our hypotenuse, of course, is L. I'm going to start with 6. Clearly, you're going to need a calculator to add up 6 squared and 23 squared. I punched that in earlier. It's 565. Doesn't say we need a radical answer, so I'm just going to punch it in the calculator and round to the 10th. What's the square root of 565? Round it to the 10th. I've got 0.8 when I rounded, so double check. We might have... Not that I would take off for that. I'm not that mean, Dean. All right, any questions on that guy? All right, that is really the basics of Pythagorean theorem. It doesn't get any more wild than that. So the next thing or the last thing I'm going to show you, if I just randomly give you 3 values, can we figure out would it be a right triangle? So we're going to do what's called the converse. So throw back to last semester, the converse of Pythagorean theorem. So you can use it to determine whether the side lengths of a triangle is right. So if then statements, throw back to chapter 2, if c squared equals a squared plus b squared, then it is a right triangle. So they're not telling you they're right. Notice there's no right angles on these triangles. There's none. We're going to figure it out if it's a right triangle or not. So we're going to test it, so to speak. So first things first, you have to figure out what's the hypotenuse. What would be the longest side? Gut instinct, what do you think the longest side is? Not a trick question. What? 3 square roots of 34. Now, I'm a little nervous about that because of the square root in it. And, you know, sometimes I like to be mean to kids and make it tricky on you. That's how I roll. So I would just double check and punch 3 square roots of 34 in your calculator. If you type 3 square roots of 34, it's going to give you a decimal. Let's make sure that is the biggest side. So punch that in. What's 3 square roots of 34 about? Yeah. So, I mean, our gut instinct was right, but you never know if the picture's drawn to scale or anything. We don't have a right angle. I can't assume it. Okay, now I'm ready to test it. So here's the question. Does 9 squared plus 15 squared, I don't know if they're equal, so I'm just going to kind of draw a dashed line to separate it. 3 square roots of 34 squared. Now, key is the right side. Notice I got fancy and threw parentheses around it, because I'm reminding you, and me, make sure you square the 3. You have to square both things there. Okay, left side's easy. Punch this in your calculator. What's 9 squared plus 15 squared? 306. So the question is this also 306? Well, I'm going to go old school here. What's 3 squared? 9. Of course, we have product really in between those. What's squaring a square root do? What's square and square root do to each other? Cancel. What's 9 times 34? That you would need your calculator for. What is 9 times 34? All right, now you can answer it. Is it a right triangle? Yes. The two sides are equal. But make sure you're conscientious that you square the 3. All the time we have kids that forget to square the 3 on that. All right, B's a little more obvious. What's the biggest side? Which one? 26. All right, so let's test it. Does 22 squared plus 14 squared, how does that match up to 26 squared? Okay, clearly you need your calculator for the left. What's 22 squared plus 14 squared? Perfect. And what's 26 squared? You got it. So is it a right triangle? Sure not, right? Right. Now, here's the next thing we're going to talk about. If it's not a right triangle, would you 50-50? Acute or obtuse? Acute. Whenever c squared is smaller, acute. If c squared is bigger, what do you think it would be? Obtuse. That's the next thing we're going to use. If it's not right, is it acute or obtuse? So that's what this picture is really just saying to you. If c squared is smaller, acute. If c squared is bigger, obtuse. So that's what we're going to fill in here on these next two blanks here. If c squared is less than, then the triangle is acute. If c squared is greater than, then it is obtuse. So that's really the next thing we're going to check. If it's not right, we're going to figure out then, or we're going to say, is it acute or obtuse? Now, the other thing we have to do as far as testing, does the triangle actually exist? Because I could just throw down 3 numbers and be like, hey guys, could these 3 numbers be the sides of a triangle? I can't just pick any 3 numbers my little heart desires. There is actual calculations that need to be done. The sum of any 2 sides of a triangle is greater than the third side for it to exist. So, a lot of calculations. It's easy, but a lot of calculations. So first I have to figure, does it exist? Then we'll figure out what style. So to figure out if it exists, the sum of any 2 sides, I'm going to pick 3 and 4, sum, add. I want to figure out, is that greater than the third side? Now, I don't have to get crazy and write a lot of work here. Just check that for me. Is 3 plus 4 greater than 6? Works. Now, I have to look at all the combinations. What if I do 3 and 6? Is that greater than the middle side? Does that check? Yeah. What if I do 4 and 6? Is that greater than the other side, 3? Does that check? All 3 of those work out, so the triangle does exist. Now the question is, well, what type is it? Acute, obtuse, or right? So now we're just going to test with Pythagorean Theorem. Clearly, my biggest number is 6. So let's see, how does 3 squared plus 4 squared stack up to 6 squared? Well, hopefully we can do some mental math on the left. You've got 9 and 16. What's 9 plus 16? And we all know 6 squared. So would you classify that as acute, obtuse, or right? And it all hinges from c squared. I heard it, obtuse. Clearly not equal, so not right. Come on. Come on, boy. C squared, of course, 36 is bigger, so obtuse. So to me, the tedious part is checking to see if it exists. Notice, and this is all you have to do too, if I ask you to provide work, notice I didn't do like 7, I didn't simplify and do all this stuff. I just mentally checked them, which you can too. So let's figure out, does it exist? So is 2.1 plus 2.8, will that be greater than 3.5? You don't have to add it, just logic sense here. Is it bigger? Yeah, sure. Okay, what if I do the 2.8 and add the 3.5? Is that greater than the third side? that going to be more than 2.1? It sure is. I don't know what it is. I just know it's more than 2.1. Okay, what if we do 2.1 and 3.5? Is that going to be bigger than the middle side? Sure. So we know it exists. Now, of course, we have to figure out the type. Clearly your biggest side, 3.5. So how does 2.1 squared man, Elliot's quick over there. I don't even have it written and he's already got it total. All right, Elliot, what did you get for this? You know it? What did you get for 3.5 squared? So what type of triangle does that result in? Right, when they're the same. Okay. Any questions on that? All right, last one. Now, this to me seems kind of odd. Does the triangle exist? I mean, they drew the triangle with it, right? But maybe we should check it just to, for the sake of math and knowledge and checking it. It's not like we're doing proofs, but we should do a little check. Let's see. You might want to think of the square root of 130 as a decimal. Punch that in your calculator, because I'm like, well, what's the square root of 130? It's about 11.4. Now, I don't think we need you to get crazy. Let's just check it. Does 10 plus 15, is that going to be over 11.4? Sure is. It's 15 and 11.4. If I add that, is it over 10? Right? 11.4 plus 10, is that over 15? So clearly it works. Okay, let's figure out, of course, what style of triangle it is. Our biggest side, 15. Let's see how that compares to 15 squared. All right, 10 squared, you know it. Square root, we talked about it earlier, of course, cancels. Probably need your calculator for 15 squared. I don't expect you to know that. What's 15 squared? 225. So, of course, 100 plus 130, I'm going to add it up. So, what type of triangle do you have? A cube. C squared is smaller, so a cube. Always based off of your C squared. I don't think it's too bad for Pythagorean Theorem, just a lot of calculations, okay? Now, of course, I know we're psyched about this. The looks on your faces are priceless. More PSAT practice problems, yes. Let me scroll it up here. Okay, now, as we talk about standardized testing, because, April will be here before we know it, remember, these are very wordy. Like, I look at this and I'm just like, oh man, I got to read all of this. What is this? But honestly, the math, I promise you, is super, super easy. So table above shows the shipping charges for an online retailer selling sporting goods. That's great. Nobody cares. Keyword, there's a linear. We've written equations of lines. We're great at lines. We know lines. Relationship between the shipping charge and the weight of the merchandise. Which function can be used to determine the shipping charge, f of x, in dollars, per order, merchandise weight of x pounds. Okay. Way back to chapter 3. This is old. How many points do I need to write an equation of a line? 2. You have 4 points up here. I'm not going to use all 4. I only need 2. And, I'm going to use the smallest numbers just to make my life the easiest. So I'm going to use this first data point, 5, 1694. And I'm going to use 10, 21, 98. 89. I said it backwards. Now, you could use the bottom 2 if you wanted. It doesn't matter. I just always pick the smallest numbers because I like to make my life easy. Now, whenever I write an equation of the line, the first thing we need is slope. How do you calculate the slope? What's the formula?
This one by 1 over x, 2 minus x1.
So, I haven't done anything crazy complicated. I'm calculating slope here. You're calculating slope. Punch it in. All right, what do you get for the slope? So if you round 1, but let's look at our multiple choice answers here. I'm going to scroll it up just a little bit. So I'm looking at the choices. Which two have a slope close to 1? A and B. So I'm between these two. Because you should get about 0.99, whatever you wanted to round to. Now again, I haven't done anything that hard. We've calculated slope. It's not that hard. Here's the thing. Of course I'm going to do the math, but we should be able to make a gut instinct. Which do we think the answer is? The top one with the y-intercept of 0 or B with the y-intercept of 1199? It's probably B. We'd probably B with the 1199. Elliot clearly is proud of himself. He guessed it. Okay. Now, to make sure, of course, we really probably should do our point slope form. I'm going to use the first point. And of course, if you go through and distribute and solve it, you will get B. Okay. But again, biggest, hardest thing I did was calculate the slope, and I could have figured out the answer from it. You just have to bear through or grit your teeth and do all the reading and figure out it's a line and you need the slope. It's not that hard of a problem. That's why I would not want you to miss that.